All right, so let's talk about an idea in the world of data stores that sounds, on the surface, absolutely brilliant. The perfect cost-saving hack. But what happens when that brilliant idea turns out to be a total disaster waiting to happen? Well, that's exactly what one system administrator found out.
So this is the big question, right? You've got these lightning-fast solid-state drives, and you've got these huge, cheap spinning hard drives. Can you just mash them together in one system? Is it a genius move for your budget, or are you just carefully building a data Jenga tower that's about to come crashing down? Let's dig in.
You know, every one of these tech tales seems to start with a dream. And this one is no different. It's the story of a sysadmin with a really noble plan. And honestly, it sounded totally logical. He wanted to build the perfect storage system.
And we're not talking about a small dream. The ultimate goal here was data immortality. I mean, think about that. The idea was to use a system called Ceph to build a storage cluster that just doesn't fail. It heals itself, it replicates everything automatically. It really does sound like pure magic, and you can totally see the appeal.
So here was the plan. It was for a small school, a pretty modest setup with just 2 servers. And the idea was simple. Use the fast SSDs for things that need to be quick, like virtual machines, and use the big, cheap hard drives for bulk stuff like backups. On paper, it looks perfect, the best of both worlds, speed and capacity. What could possibly go wrong?
And this is where things get interesting. This is the exact moment that the perfect, elegant theory slams headfirst into the messy, unforgiving reality of how distributed systems actually work. The Jenga tower is definitely starting to wobble.
So our admin, feeling pretty good about this plan, posts it online for some feedback. And the internet, well, it did what the internet does. The response was, let's just say, direct. This quote here pretty much sums up the vibe. A really harsh, but probably very necessary, reality check.
The first big red flag was just a simple problem of scale. The admin figured, hey, 2 servers, that's a good starting point. But the reality of Ceph is, it's just not built for that. To get that magical high availability everyone talks about, you need at least 3 fully loaded servers, minimum.
And this is where the math just gets painful. All that self-healing and data protection doesn't come for free. It costs you storage overhead, and on a tiny cluster, the cost is insane. So that 14 terabytes of raw storage the admin thought he had, after Ceph's safety features kick in, it shrinks to less than 1.4 terabytes of usable space. That's a 90% loss, just gone.
So, you might be asking, what's the big deal with having an odd number of servers? Well, it all comes down to this thing called quorum. The easiest way to think about it is like an election. If you have a vote, you need an odd number of voters to avoid a tie, right? Same idea here. With only 2 nodes, they can disagree, and you can get what's called a split brain, where both servers think they're the boss, and that leads to data corruption and chaos. It's bad news.
Okay, but let's just say you get the number of servers right. Let's say you have 3 or 5. You're still not out of the woods. There's a much deeper, more fundamental problem here, and that's what we'll call the fast versus slow trap. This is the real technical reason you can't just toss SSDs and hard drives into the same bucket and hope for the best.
And this brings us to what is, without a doubt, the golden rule of this whole thing. If you take one lesson away from all this, let it be this. You can absolutely use hard drives, you can absolutely use SSDs, but you cannot ever mix them together in the same operational pool. That's the rule.
So why is that such a bad idea? Well, I love this analogy because it's perfect. Imagine you're in a Tesla, ready to race, but you're towing a U-Haul trailer filled to the brim with sandbags. The Tesla's engine is screaming, it wants to go fast, but it doesn't matter. Your speed is completely limited by that giant, slow, heavy thing you're dragging behind you. That's exactly what happens with your storage. Let's break down exactly how this goes wrong. So, your system needs to write some data. The SSD, being an SSD, does its part in a flash. It's instant. But, and this is the big but, that old mechanical hard drive, it's still physically spinning and spinning, trying to find the right spot. And here's the kicker. The entire operation has to just sit there and wait until that slowest drive finally says, okay, I'm done. Your incredibly fast SSD is now a hostage, completely at the mercy of your slowest drive. All right, so I know this all sounds pretty bad, like you should never even think about doing this. But it's not actually impossible. We've talked a lot about the problems, so now let's flip it around and talk about the solution. Because there is a smart way to do this, if you're careful. The whole secret is a feature inside Ceph called device classes. It's actually pretty simple. It's just a way to bring some order to the chaos. All you do is label your drives. You tell Ceph, hey, this pile of drives over here, these are my SSDs. And this other pile, these are all my HDDs. You're just telling the system exactly what it's got to work with.
And once you've done that, you can follow this blueprint right here. This is how you make it all work in harmony. You create totally separate pools for each type of drive. So as you can see, stuff that needs speed, like your virtual machines, you point that to a pool that is only made of SSDs. Meanwhile, all your bulk storage, your backups and archives, that goes to a different pool that is only made of HDDs. See? You're not mixing them in the same bucket anymore. You're separating them intelligently.
Now, out of all this, there is one rule that is absolutely 100% non-negotiable: your metadata. Think of metadata as the map for your entire storage cluster. It's what tells the system where every single piece of data is. That map has to live on your fastest storage. It always goes on the SSDs, no exceptions. Because if the map itself loads slowly, then everything you do on that cluster is going to feel like wading through mud.
Okay, so let's boil all of this down to the final takeaway. This is the wisdom that was earned the hard way, right? And it applies to everybody. Whether you're just messing around in a home lab or you're a pro building a massive cluster, this is what you need to know.
All right, here are the rules, plain and simple. First, never ever mix drive types in the same pool. Got it? Good. Second, use those device classes to label all your drives. Then, create separate pools for each of those classes. Make sure you point the right workloads to the right pools. And like we just said, your metadata always goes on the fastest storage you have. And the last one is a big one. Understand your failure domains before you even start building. That's just a fancy way of saying, think about what happens if a whole server dies or an entire rack of servers loses power. Plan for the big stuff.
And you know, for anyone running a small setup, like our original sysadmin, Ceph can honestly be what you'd call a high-anxiety system. It is incredibly powerful, but it is also incredibly unforgiving. Sometimes the right tool for the job is something simpler. Something like ZFS replication might be the much smarter play. It's not real-time, it's not as magical, but it's super stable, reliable, and for a lot of people, it's more than good enough.
And really, this gets to the core of everything we've talked about. Building a really solid, efficient system isn't about getting lucky, and it's not about just buying the most expensive gear you can find. The real difference between a rock-solid system and a wobbly Jenga tower, it's all about architecture. It's all about the plan.
So I'll leave you with this one last thought. Take a hard look at your own systems, at where you keep your important data. Is it sitting on a solid foundation that you've carefully planned out? Or are you maybe just one bad move away from watching a Jenga tower of your own creation come crashing down?